quiz, or do you want to start with the preparation assignment?
We can start with the preparation assignment. I finished it up too. So.
Can you see that?
Let me see. Hold on a second.
Can you see my screen?
Yeah, I can see yours too.
Okay. Okay. So use the information in the reading assignment to complete these questions. What notion is used to denote the probability of an event occurring? Let me get mine. So that was just P and then parenthesis X, right? The notion.
Yeah, that's what. Yeah, that's what it was.
Okay. And please state and describe the three rules of probability. The first one was, well, okay, so this is what was confusing to me because at one point in the book, they gave in the notes, they like started saying something like probabilities can't be negative, probabilities can't be larger than 100%. So I was like, I started writing those down as if they were the three rules. But those weren't the three rules. Apparently, the three rules are that probability of x is a number between 0 and 1. So I guess they are, but I was confused at that because when we started doing like Z-disc and stuff in lesson 5, we had some negative, I don't know. I'm confused.
Yeah. No, I understand. The rules didn't make any sense to me either because I was reading through them and then I saw this and then the percentages and stuff. There was like two different things that were different. So I was in the same boat as you.
Yeah, because I guess that makes sense if it's the where you type in on that like graph where you can manipulate the two z-scores. Maybe it can't be negative up in the average part in the box where you type in.
Oh, okay. Yeah, I see.
And then rule number 3. Sorry, I'm sick. So,
No, you're fine. Don't worry.
Rule number 3 is the complement rule. It's the you take P and then not X or the individual, or no, you take the 1 minus the individual. So 1 minus P, and then, yeah, the variable. So what does it mean to be random? Any random process follows a distinct pattern over time. You never know what the outcome is going to be.
Yeah.
So then what does the phrase discrete random variable mean? And let's see, that was number 4. It's something that varies following a specific pattern or distribution over a long run. They are discrete if they can be listed. Did that confuse you at all, or
no? I don't know. It was kind of weird at first. I was like, well, this didn't explain in the book exactly. It just said like it's discrete, can't be defined or something. And I was like, okay. At first, I didn't really understand it.
I'm trying to think of an example that they would have used in the chapter that would have been discrete.
No, I wasn't. I don't. That was a little difficult, a little bit.
Let's see. So, what proportion of the time do you think you would avoid? Oh, yeah, okay. That makes sense. So that was where you had the dice, and you can, there's 6 numbers or 6 sides on a die, so total number is 6. And the probabilities, you could roll a 1 out of 6.
But yeah, like every time.
And then many people think that 3s mean, okay, so I guess that's an example of discrete.
Hmm.
Okay. Let me go back here. And then you will fill this part in during your group preparation session. Okay, so an 8-sided die has 8 possible outcomes for each roll. Calculate the probability of rolling a number 5. So wouldn't that just be 1 out of 8? Or
See here, an 8-sided die has 8 possible outcomes for each roll. Okay, the probability of rolling a number greater than 5.
oh, you know what? I'm looking at the answer key and it says 3 out of 8 or 0.375. So I think there might be a table that we're supposed to be looking at. Then the oh yeah, okay. No wait. That's a 6-sided die. Can you see my screen?
Yeah, I can see it.
Okay. I feel like that was in the book, but maybe we're supposed to just go off of something like this, except it's supposed to be an 8-sided die.
But I wonder, how do you know it's 3 though?
So how did you get?
I think I figured this out. Okay, so 5 plus 3 is 8. So my guess is it would be 3 out of 8. I don't know. Maybe that's wrong. No, I don't think that's right.
Roll greater than a 5.
Because the next one says the same thing.
Let's see.
Getting a number greater than 5.
Well, there are 3 digits greater than 5, right? 6, 7, 8.
Yeah, there is.
So I guess maybe it's you just take whatever's left of the whatever comes higher. How many variables after the 5? So there's 3 variables, which means you could roll up to 3 eighths higher, or the probability of rolling greater than a 5 is 3/8 because there's still 3 variables you could pick above 5.
Yeah, no, I'm not sure. I'm not sure if that's right, but I mean, probably. I mean, I would guess it is.
What? And then 6 says, let's go back to number 6. I probably am wrong too. Calculate the probability of not getting a number 5 greater than. Oh. Okay, so this is the rule where you take the number value that it occurred, and then you total that number roll. So you divide.
Mm-hmm.
So let's see. Since all numbers are equally likely, we would expect to roll each of the values 1 through 6 about 1/6 of the time. This is basing off the 6-sided die, but I don't know. Let's see. I think that's just like the last question on our preparation assignment finding. Anyway, I think that is where you take the variable 5 minus 8 and then divide it by when you take 5, 5 minus 8 is 3, and then divide by 8. So I think that's right. You would use the number 3 rule, the probability that an outcome will not occur, is 1 minus the probability that it will occur.
But it will occur.
Sorry. Let's see. I'll go back to my notes. I think this rule number 3, probability. So I'm thinking that's because if you take 5, the individual variable minus the overall, or so 5 minus 8, right? It's 3, yeah, and so that would be the 3/8. And then, that's if it will not occur. I don't know. I'm confused. And then you just do 3 divided by 8, which is that 0.375. And then, no, you use that rule for number 6 in the preparation assignment. Not roll greater than 5. I would assume that's that rule. The probability that an outcome will not occur is 1 minus the probability that it will occur. So then 5. No, I don't know. We'll figure it out. I don't know. I think I did the quiz, and then I don't know. See, I take all my quizzes on Saturday because that's really the only time I have to do this homework.
I'm doing.
So by the time, I probably should wait to take it and just do what you were doing this morning and just take it first thing before. Okay, but we kind of understand how to
do it. Yep.
I don't know why I'm not understanding six-sided die. It has to just be like the 6-sided die example in the book, I'm assuming. But...
Yeah, I think it's probably just like the 6-sided die. I agree.
Okay.
So if we do...
let's see. Do you want to share your screen and then we can finish your quiz together?
Yeah, I can share.
Okay.
Yeah, I can share.
Okay, let me stop sharing mine really fast. Oh, wait. Okay. Did I stop sharing it? Okay.
Yeah, you did.
Okay.
Can you see mine?
Oh, yeah. Let me click on... There you go. Yeah, okay.
Okay, so I'll answer these first two. But anyways, no, you're probably answering. Okay, so use the following information to answer the next question. Next problem. Human blood can be classified into one of our basic types: O, A, B, and AB. So the proportion of people in the population of the United States with each of these blood types is summarized in the following table. Here's the table. 0.45, 0.0. The blood types and the proportions given in the table above define a probability distribution. I put true.
Yeah, that's what I put too, because they all add up to 100%.
Yeah. What is the probability that a randomly selected person in the United States has type O blood? Well,
wouldn't you take the O, the percent, the decimal of O, and then subtract it from 1, and then divide by, there's 1, 2, 3, 4 variables. Or I don't know, how would you have done that if had I not just said that? I don't know if that's right.
I'm not sure. Look at the book here, if we can.
Try scrolling up. Let's see. what's that number 12 say? Student estimated the probability that he would finish his homework 0.45, and the probability, or 45%, the probability that he would not finish his homework is 0.35. 35%. What is wrong with the students? So I'm assuming that we have to. Let me look at my notes.
I think that's right. The 55% for the first one, or well, I guess 0.55.
Oh.
For this one right here. But I'm wondering if I'm doing it wrong, because I remember was there an assignment? I was watching the videos from the teacher, or not the teacher, but the ones that they do in the book up here in the corner. These ones right here. He was going through it, but I don't understand how I got it. I'm gonna go ahead and try this.
0.55. Okay. So how did you do that?
I just did my I looked
45.
blood type here with the proportion being 0.45, and then I just took 1 minus 0.45. It gave me 0.55.
Okay, so you subtracted it from 1?
Yeah.
Okay, and then you divided it by. Oh, you didn't divide it. You just subtracted it from 1, right?
Yeah, just subtracted by 1 from 1.
Okay. That makes sense.
That's my guess on that. There's a probability that a randomly selected person will not have type O blood. Round 2 decimal point. Well, I think this one is.
So that would be 1 minus 45, right? To find, because you'd use the complement rule to find that one, I think.
If I use the complement rule on that one, this one would have been 0.55, not number 4. So if I was to do number 4, What would that be? That would be negative 0.55. I don't.
Sorry, I have no help today. I'm trying to remember.
Oh, no, you're fine. Oh, A, B, and A, B. People publish.
So how did you get the answer? Did you answer number 4 then?
I put it in here, but I don't know if this is right. 0.55. If I use the complement rule for question 5, that would be the answer for question 5.
No, I think number 4 is right. And then you would use the complement rule for number 5. I'm just trying to remember why. Because you would think that you would just take one, because usually you're taking to find the well, we're not trying to find the sample mean. I keep thinking that we're trying to find the sample. I think what you do is you divide.
Divide.
Try taking the for 0.45 for type O blood.
Yeah.
And dividing it by 4. That might not be right. But in my notes, when they were doing the dice, one of the questions they asked is, what is the probability of rolling a number 6 and not rolling a number? Okay, so not rolling a 6 would be, they said it would be 5 divided by 6 because you're taking one of the variables out. What they did, anyways, they divided 5 over 6 and got 0.833. Let me go to the book really fast.
No, you're fine. I mean, I'm looking through this too.
Okay, yeah, keep going.
Kind of a big number though for blood types. If you were to use that, it's 3 though.
Okay, so to not find something, you just take 1. So and you just minus it, minus the sorry, I just asked my husband because I can't remember. And he was just saying to take 1, use the complementary rule and take 1 and subtract it from, so type O blood is that 0.45, and that should be your answer for that one.
Take 1 minus 0.45.
Yeah, 1 minus 0.45, which would be.
That's this number then. It would be 0.55.
Yeah.
And this one has to be different though.
Okay. 0. Let's see.
So if I was to do that.
Well, we're getting 0.55, and that was for the first question on the quiz.
0.55 for the Idaho?
No, this is homework. This is separate, but it's a similar question. Let me go back. So we're doing number 5. What is the probability that a random selected person will not have type O blood?
Okay, go. What are your percentages?
So for typo, it's 0.45.
And it's not 0.55?
No, I think that was number 4 is 0.55 because that one is what is the probability that randomly selected person in the United States has type O?
And that it was correct.
Yeah, and they all add up to 100.
And in the quiz, the 0.55 was correct for.
Remember? That's what I. So what would be number 4 then?
Number 4 is 0.45.
Oh, okay. So it's just the decimal.
Yeah.
Okay.
Because if the probability is right in the table.
Okay.
Because it's the 0.45.
So then
the other one.
You would use the complementary rule and 1 minus 0.45 and get 0.55. Okay. Yeah. Okay. Okay. So let's see. Does that make sense, Chad?
Yeah, I heard him. Thanks. I appreciate
Yes, thank you.
figuring that one out. So.
Okay. You got this.
All right. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. Dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tango, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. One of the samples came from a person identified as a bladder cancer patient. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimens from the bladder cancer patient? Okay.
So you have 7 bowls containing the urine were lined up in a random order. 6 of the samples were from patients who did not have cancer. 1 of the samples came from a person identified as bladder cancer. So random, what is the probability that they will correctly identify the dish containing a specimen? Wouldn't it be... So we have to give it a 3 decimal place. Would you just divide 1 by... Or 7?
Those are 7 bowls. I could put that. Let's see. Where are these guys? Yeah, I think that's 1 divided by 7. Like 1 and 7 or whatever it is.
Okay.
I'll put it.
I actually went
combined
and pulled
total.
up my quiz. Let's see.
Oh, okay. Cool.
So for number 6, I got 0.143. So is that what you got when you divided one?
Yeah, when I got
by
the
some-
same one divided
Okay.
6.
It's crazy,
combine-
like if you don't keep doing the same stuff, how easy it is to forget it.
Oh, I know. I was working on this a couple days ago, I think so, and I was like, well, I'll go back and look at it again before my meeting, and I was like, I don't remember anything.
Yeah, that's what I feel bad. Sorry.
No worries. Don't worry about it.
Okay, so we're on number 7, right?
Yeah, number 7. And combined total of 54 tries. The dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? Provides strong evidence that dogs can detect bladder cancer. There is little evidence that dogs can detect bladder cancer.
So I did put this provides strong evidence that dogs can detect bladder cancer, and I think I put that because, which I did end up getting it correct. I put that because 22 is a lot closer to 54 than, if it would have been like 10 or 14, I think that would have been little evidence, but because it's so close to
The actual trial.
it's more likely, stronger evidence that the dogs can detect bladder cancer.
That makes sense. I think that's in the book somewhere. It talks about something like that, or something close. I'm not sure. Use the following information to answer the next 2 questions. M&Ms are small chocolate candies.
Anna just texted me and said, "Good morning. Are you up?"
Oh yeah, we're up on. I sent over an invite for her.
Okay. Let me. You keep working on your quiz. I'm gonna give her a call really fast and tell her that we're to look at our email.
Yeah. Okay.
Hey Chad, she never got an invite. Do you think you could try sending one again?
Yeah, definitely.
He said he'll send one again. This is what was happening to me the other day when I was trying to set up the quiz with everyone. Like for some reason, some people got it and some people didn't. I think we're going just can be glitchy sometimes.
Weird. I wonder why I didn't. This one text. Just start. Thanks.
Can you hear me?
Yeah, no, I can.
Oh, perfect.
Sorry that it worked this morning. So bad.
Did you guys just start it or?
Yeah. Well, do you have your quiz pulled up?
Sorry, what?
Do you have your quiz pulled up?
Yes.
Okay. We can go back to the beginning and if you want.
So did I miss something?
How far on the quiz did you get?
I was working, I think I'm in number, hold on, I'm in number 7.
Okay, that's perfect. That's where we are. If you want, we can go back and compare answers though before we move on.
Okay, question 1 true, I guess. Question 2 true. Okay, here. Question 3, I put true.
Yep.
When you add all up, it's 1. Is that correct?
So yeah, for number 1 is true, 2 true, and then 3 you put true.
Yes, I'm number 3.
Okay, yeah, those are correct. Yeah.
Because when you add it, it's 1.
Right. When you add it to 100, yeah, 100%.
Okay. I was a little confused about it. It made me I'm not good at this. So I thought it was 0.45.
That's right.
45%. Is that right?
Yeah, that's right.
Yeah, so you would just round to the nearest decimal, so it would just be the 0.45. Chad and I actually, we had to get my husband in here because we couldn't remember. The 0.45 is just taking the variable from the data chart. It's just what the probability is for type O. So that's where yeah, you were right, the 0.45.
Oh, yeah, of course. Oh, I knew that. Type 4, type 0, A, B, and AB. I'm O positive. Oh,
Yeah.
sorry.
No.
That's funny. That will be 0.55, which is what's left.
Yep.
Okay. And then in 6, I think 1/7, which is 0.143.
Yeah.
And you understood question 5, okay, Anna?
Yeah, she did. She got 0.55.
Okay. So number 7 then?
I was barely started to get it. So I don't know if it's in a combined total of 54 trials. The data specimen from the cancer patient 22 times. So you have 2 values right there. It is very unlikely that the dog will do this well, random chance alone. Which of the following statement is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There is little evidence that dogs can detect bladder cancer. So I'm thinking the first one, because it's a high 20 is a high number.
Yes. That's what I got. I because you're more, I think you're closer to 22 times that, if it would have been like 10 times or 14 times, I think that would have been little evidence, but because it's a bigger number, this provides stronger evidence. I don't know if this question is more of a just like you're not assuming, but you're like estimating,
Yes.
But yeah, that's what I put too. This provides strong evidence.
Now, how do I see you again?
Oh, are you looking at Chad's screen?
Yeah, and I on the left, but not on the right. I lost you. Like I can see video call.
Oh, just click on my screen, like down in the corner of your thing. If you click on my screen, you should just be able to see my screen without it switching off every 5 seconds.
Oh, I know, but it just makes my picture in the back, not like my computer picture, what I have in my screen. I can hear you though. That's weird.
Did you try clicking on the little box that says chat at the bottom?
Chat at the bottom. No, I only have. Can you see my screen? Or I'm not sharing it.
I can see chat screen. Oh, are you trying to share your screen right now?
No, it just on the left just shows. It just shows.
But you have your quiz pulled up, right?
Yes, that's why when I went to the quiz, when I go back and now it's just like I'm not talking to anybody. I can hear you though, Indians. It's okay. We can just keep going.
Okay.
It's just that I'm not able to see your quiz. Okay, so number 7. M&M's are small chocolate candies.
So I don't think
Sorry.
Chad, are you there?
Yeah, I'm here.
Okay. So we're on number 8.
Oh yeah, 8.
M&Ms are small chocolate candies. The M&Ms website previously indicated in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. So if you reach in a bag of plain M&Ms, what is the probability of drawing a red colored candy?
I think it's just the probability of 0.13.
Yeah.
Say
What is the probability? Yeah, 0.13. What is the probability that a randomly selected candy is green? Drawn up here, green is not shown.
So we have to find out, don't we have to add all those up and then subtract from 100 to get the percentage for green?
I think so.
is a decimal. The answer is a decimal. It's not percentage, right?
Right. But I mean, generally it's a percentage like that. Like brown is 13%.
So we all
They put it in decimal form. Yeah.
When you add them all up, does it give you 100 or 1?
Yeah, so the table should, if it's correct, it should, all of those variables should add up to 100. If you're missing one variable, you know that you can add up all of the ones that you do have and then subtract from 100, and that should give you the percent or the decimal.
So they all together are 0.84.
And then subtract that from 100.
Is 0.6.
You got 0.16?
Uh-huh.
Yeah, that's what
That
I
would
have
be
it
green.
too.
That should be right. 0.16.
The question, a red color. So that will be just 0.13, right?
Yeah, because because that probability is already given from the table, it would just be that 0.13.
Yeah. You cannot want to make it more complicated. It's not as bad. I'm trying to say.
Do you understand how you get that, Anna?
Yes, yes. I'm trying to like I think it's like I have and it's like easier than what you think.
So we're on number 10.
Yeah, this is saying whether that the randomly selected candy is not green. So, 0.84, right?
0.84. So that's where that complementary rule comes in. 1 minus, and then, okay, so that makes sense then.
Yeah.
To get that, wouldn't it be 1 minus 0.16?
Yeah, that's what I did.
Right, and then it's 0.84.
Yeah.
Yeah, so yeah, it'd just be 1 minus the variable or the probability from the chart to get the 0.84. So do we want to move on to the next one? Does that make sense?
I get it. Anna, you okay?
Yeah, 0.16, right?
For the green.
Well, number 10 is 0.84.
Yeah.
Okay.
Okay, wait, I haven't read the probability that a randomly selected candy is not green. So it will be just 1 minus 0.16,
Yeah.
Right.
right? Which is 0.84. Is that right?
Yeah.
Are you good to move on, Anna?
Yeah, so we're in
The last three
the
questions.
following information for the next three.
Yeah, number 11. Number 11.
Okay.
This is the ACT scores of students admitted to a medium-sized public university in the Western United States were taken from capix.com. The following summary statistics were calculated. Question 11 says half of the observations are less than or equal to what number?
So we need to find the average. Right? Half of observations are less than or equal to what?
I don't know.
So do we find the sample mean?
What's that?
We find the sample. We need to find the sample mean, right, for that one?
Half of the observations are less than or equal to what number? Would this be? I don't know if it's. Yeah, I think so, but maybe it's
Medium. The medium is right what's in the middle, right?
Yeah, the median.
So it will be 24.
Yeah.
Mm-hmm.
Sorry, not the sample mean. Yeah, median.
I don't know. I'm thinking the number right in the middle of the values that we have. And it says half of the observations are less or equal to this number.
Yeah, but it says median 24. So yeah, you're right. That'd be the 24. Because if you look in the chart, it's the median. They give you the median.
$24.
I think so. So Remind me again, Q. What? That's Q1 and
Q
Q3. I'm thinking the next one has to do with those Qs.
minimum is, minimum's the smallest number. Then Q1 is usually the 25 percentile.
Yeah, so that's what I'm thinking is Q1. But remind me again. I think it is Q1 above. Is based on the information. So the top 25% of the students score above what number? Oh, the top 25.
So I don't think it would. Let's see. I think it would be you would be looking at Q3 for the top 25.
Yes. Q3. I thought it was the first 25.
The top
So it's the
25%
top
of the
20.
students scored above what number?
It would be 27.
Yeah.
Mm-hmm. Einstein does not want the three rules of probability. That's probably as high as
First and second are true. Maybe the third one.
Yeah, that's the third one.
The longest one, right? If the probability is high, then the probability is positive. True, because there is no such a thing as positive and negative in probabilities.
Yeah, it's not because if you sum all the probabilities, it should equal one. The probability number between 0 and 1. That's rule number 2. Rule 1. I think the complement is up on the top. That's rule 3 on the top. Rule 3. Rule 1.
I would pick 2.
Yeah. All right. Well, I'm gonna go ahead and I'm gonna.
Did you guys turn it in?
It looks like Chad just turned his in. So far, so good.
Yeah,
Did we get it right?
Yeah, we got them right. All of them.
So did you guys started at 6:30 and you just couldn't connect with me? Is that what happened?
I don't know. I don't know if the invite worked really well. I might have put something in wrong. I don't remember. It's probably my fault, so I'm sorry, Anna.
Oh no, that's fine. I just want to know if my computer is the problem.
No, I don't think your computer is the problem. It's probably my fault.
Oh, because I can see you right now. Like yeah.
You can see my quiz and stuff.
No, I can hear you guys, but I can see. I'm trying to. Like I have a.
I know. I can stop.
That's okay.
I could stop sharing my screen here. Let's see.
See, I can see.
So do you guys want to do a morning meeting on Thursday or at night?
I don't mind. If we do like 6:30, 6:45.
Did the time this morning work for everyone?
Yeah, it's hard to wake up, but yeah.
It works for me too.
I think it's easier than telling my husband to put the kids to bed by himself. You know what I mean? But we can try both. Like if we can get the system, then at least we have the chance to do it at nighttime. So maybe we should try morning, and if it doesn't work, we still have a chance to do it later in the day. You know what I mean?
Yeah.
Yeah.
Yeah or
So
no?
did you want to do 6:30 then, same time on Thursday?
Yeah. I
Yes,
mean,
me.
I'm okay at 6:30.
I,
Too early, Anna?
yeah, that's fine. And just text me if you can connect with me. So
Yeah.
I read in the lesson and I'm not like I'm just checking so I can like pay attention and like really, really wait for your call.
Okay.
Okay. So do you want Chad? Do you want me to take a turn leading it this time on Thursday?
That'd be great.
Okay. I'll set up the meeting then on Thursday. And Anna, I'll text both of you. I'll just send the invite like right when I get on. Right at
That's a great idea. Yeah, just text me say like, okay, I'm gonna call you right now. And so I'm like, okay.
Okay, sounds good.
Okay.
And so 6:30 Mountain Time, which would be okay 5:30. Okay, yeah, that works great. That actually works good because my son he wakes up at 7, so doing it my time 5:30, he's still asleep and everything, so it works good.
Uh,
All right,
yeah.
well, see you guys Thursday then 6:30 Mountain Time.
Okay.
Sounds good. All right. Take care.
Thank you guys.